Let's be real, when we talk about cloud security, it's so easy to get totally lost in a sea of checklists and complicated jargon. But what if we thought about it a different way? What if we were building a digital fortress? Well, today, that's exactly what we're going to do. We're grabbing the blueprints, using the AWS well-architected framework as our guide. Let's get started.
So, what is this blueprint really? At its heart, the security pillar isn't just some boring set of rules. It's a whole design philosophy. It's all about using the power of the cloud to build something that's even more secure than you could on premises. This is our foundation, the very ground our fortress is going to stand on.
And here's our game plan for building it. We're going to start with the core design principles, the blueprint itself. Then we'll move to guarding the gates with identity management. After that, it's all about building our layered defenses, protecting our most valuable data, our crown jewels, and finally, getting ready for the inevitable siege with a rock-solid incident response plan.
You know, every great fortress, every castle, it starts with a solid blueprint. And for our digital fortress, that blueprint is built on 7 core design principles. These are going to guide every single decision we make from here on out.
Okay, so these are the 7 pillars of our security philosophy. Now, instead of just reading you a list, let's zoom in on 2 really critical ideas that we're going to see again and again. First, apply security at all layers. This is our defense in depth strategy. It's like having not just a wall, but also a moat and watchtowers and guards. And second, keep people away from data. This might sound a little strange, but human error is a huge security risk, so automating access is almost always the safer bet.
All right, with our principles in place, let's start building. A fortress is pretty useless if you can't control who's coming in and out, right? That is where identity and access management comes in. This is all about deciding who gets the keys to the castle, and this is the important part, which specific doors those keys can open.
And this right here, this is the absolute golden rule of access control. The principle of least privilege is actually super simple. You only give a user, or a service, the exact permissions they need to do their job, and not a single permission more. No master keys for everybody, just the right key for the right door at the right time.
So what about those keys or credentials themselves? Well, the best practice is this simple 3-step mantra: remove, replace, rotate. First, just get rid of any keys you don't actually need. Then, replace any of those long-term static keys with temporary ones wherever you can. And for anything that's left, rotate them, automatically, and often. This makes a lost or stolen key so much less dangerous.
Now, this is where it gets really practical. For example, instead of sticking a permanent access key in your application, which is like leaving a key under the doormat, you replace it with something called an IAM role. Think of it like giving your app a temporary key card that only works for one specific job and then expires. For things like database passwords, use a service like AWS Secrets Manager to automatically change the locks every few hours or days. You see, you're not just managing keys, you're designing the risk right out of the system.
Okay, our gates are secured. Now it's time to build the walls. And I don't mean just one wall. We're talking about multiple, overlapping layers of defense, from the very edge of the network right down to the inner hallways, protecting our most sensitive systems.
And this goes right back to that core principle we mentioned earlier, defense in depth. The whole idea is that if one security control fails, and you should always assume one might, another layer is waiting right behind it to stop the attacker. You know, a single high wall is good, but a series of walls and moats and watchtowers, that's way, way better.
In the cloud, these layers look something like this. You start with protection at the very edge of the AWS network. Then your virtual network and subnets act as internal walls. You secure your load balancers, the individual computers themselves, and then finally, the application code. Every single layer gets its own set of controls.
This is such a fundamental part of that layered defense. You wouldn't put your public-facing web servers in the same room as your critical databases, right? It's just like a castle. You have a public courtyard where anyone can go, and then you have the heavily guarded throne room. Your cloud architecture should do the same thing, using network layers to create these zones of trust.
Okay, we've guarded the gates, we've built the walls. So now, let's talk about what we're actually protecting: the data. These are the crown jewels of our digital fortress, and they need some very special attention. 2 of our most powerful tools for protecting these crown jewels are encryption and tokenization. Now, encryption basically scrambles the data, so it's unreadable without the right key. Tokenization is a bit different. It replaces the sensitive data with a non-sensitive placeholder, a token. Both are super important, but they solve different problems.
Encryption protects the data itself, while tokenization can actually reduce where that sensitive data has to be handled in the first place.
And all of this comes back to a really simple truth. You can't protect what you don't understand. Data classification is just the process of figuring out what's public, what's internal, and what's top secret. I mean, you wouldn't guard a loaf of bread with the same intensity as the crown jewels, would you? Classifying your data lets you apply the right level of protection to the right assets, which is just smart.
No matter how strong our fortress is, we have to assume that one day it will come under attack. A security plan just isn't complete without a plan for what to do during a siege, and that's incident response.
So, preparation starts with knowing your enemy. Threat modeling, which you can see in this risk matrix here, is really just a structured way of thinking through what could go wrong. By figuring out how likely and how bad different threats could be, you can prioritize your defenses and focus your energy on the stuff that poses the biggest risk to your fortress.
And one of the absolute best ways to prepare for a siege is to practice.
By running simulations before you have a real incident. Think about it, right? You don't wait for a fire to test your smoke alarms and practice your escape route. It's the exact same for security. Running simulations in game days makes sure that when a real crisis hits, your team knows the plan, they have the right access, and they can respond calmly and effectively. And that response, it follows a pretty structured process. You collect evidence, you examine it, analyze what happened, and you report on it. But honestly, maybe the most important step is that last one, lessons learned. The real goal of responding to an incident isn't just to fix the problem, it's to learn from it and make your fortress even stronger against future attacks.
And that really brings us to the most important lesson of all. A fortress is never truly finished. The threats out there are always changing, so our defenses have to change too. Security is not a project you just complete and check off. It's a living, breathing process of continuous improvement. So, I'll leave you with this question to think about. When you look at your own security posture, what do you see? Is it just a static checklist of items you ticked off a year ago? Or do you see a dynamic, living blueprint that adapts and evolves to protect your own digital fortress?